So we are going to focus on the 2 to 3 of the 15 questions that are called calculator active, which means you have to use your calculator to get the right answer. Most of the questions on the calculator portion, you don't need to use your calculator at all, / your calculator won't even help you. Like you'll be given graphs. Having a calculator will not help you on 12 of these 15 questions. We're going to focus our attention on the 2 to 3 calculator active questions. Now we have our calculators. What we need to do is make sure our calculators are ready to be used, which means you should be in radian mode. And probably safe to just reset everything, okay? Get your stat plots off, get all of your diagnostics off, just get everything set up for success. Everybody should know second plus 712. Reset your calculator and all of its settings and put your calculator in radian mode, which is the standard mode. So we press second plus 712. You should see RAM cleared. That's good. Cool? All right, that's the first thing we need to do. The second thing is to just understand some buttons that we're going to use often. For example, the variable x will be graphing. Hope everybody knows this is the shortcut X button. In the home screen, X is usually assigned a value, like 0. So if you press 5x, your calculator does 5 times 0. Most values, letters, are assigned the number 0 to start with. Okay? But when you graph, X is used as a variable. So it can be anything, depending on your input. Okay? We'll talk about in the second semester how you can store things. Like I could say, hey, I want X to be 5. And now if I do, I want 5 to be X. I want 5 to be X. Now, if I do 4x, my calculator will do 4 times 5, which is 20. But in the y equals screen, x is a variable. Don't worry about storing. We'll talk about storing more in the second semester when it's useful. So everything's reset. We're all good. And we will get going. Now, here's the key. Even though we're going to have a calculator, this is a calculus exam, not a calculator exam. Which means, just because you have a calculator doesn't mean your calculator has all the answers. For almost all of these questions, you need to provide a setup, an equation to solve. You will need to understand the concepts that we learned in this class. And then the calculator can help you get the answer through your conceptual knowledge. So don't forget that. It's a calculus exam. So you'll need to know about limits, asymptotes, continuity. We're going to focus on continuity. Continuity says, hey, a function is continuous if limits and function values agree with each other. That's making sure your left-hand limit equals your right-hand limit, which equals the function value. Quick little review of one lesson, that's continuity. And the way we kind of asked you to do continuity questions was using piecewise functions. What you're going to see in this lesson is some no calculator examples to remind you of what you did to get the answer. And we'll do the same type of question with the calculator to see how it might be different as a calculator active question. Okay, here's the question. A that you know how to do, you should be able to get the answer 3/5. Go. And really, all of these no calculator questions, if you don't know how to do them, you have a lot of work to do, because these are very basic questions I'm putting up as examples. Just continuous. We're not talking about differentiable. Three fish.
What is you in the answer? You had some sort of like racial bias.
Well, I don't know where that came from, but no. All right, cool. So to ensure the function is continuous, I need to make sure that the left-hand limit at 1 equals the right-hand limit at 1. Many of you are forgoing this whole thing, and you're just plugging in 1 into the top and the bottom equation, which is what you do. But it's for x, not for a. So you get a plus 4a equals 3 plus the natural log of 1. You need to know the natural log of 1 is 0. You get a is 3/5. Great. If you didn't get this problem, you probably are starting off right from scratch as like, I got some work to do. Now, this is what this problem looks like as being calculator active. Now, this problem shows up. And you have your calculator. You're allowed to use your calculator now. Many of you, when given access to a calculator, immediately feel like you got to graph things and like, this has the answers. Oh, thank you. I have the answers here. I just have to figure. No. You have the concept. You know the setup. Your calculator will just do the last step for a majority of these problems. You know that this piece and this piece need to meet up at 1. Okay? What did you do on the last problem? You plugged in 1 into both equations. Okay, so you got a sine 1 plus 1. You have log 1 plus a cubed. You were able to solve an equation like this on the previous page. You can't solve this equation by hand. This is where your calculator comes into play. So the first thing you need to learn is how to use your calculator to solve equations. Okay, ready? You will graph y equals the left side, but you're going to use x's instead of a's. But like x, it will represent a's. And you will graph y equals the right side. So everybody, let's graph y equals the left side and y equals the right side. Okay, you all have a calculator, right, fish? Go get one. Because if you're not doing this, you're not learning. All right. So I have y equals, instead of a sine 1, I'm going to put x. I found the x button, x sine 1. I will close off my parentheses so that it doesn't think that I'm adding more stuff into sine. I will add 1, and that's y equals the left side. If I wanted to, I could use the home screen and plug in what the sine of 1 is. I don't know what the sine of 1 is. It is not an angle I'm familiar with. On the right side, I could type in log 1 plus x cubed, or just x cubed. I know that the natural log of 1 is 0, but, you know, a lot of you lose all semblance of confidence that you have in your mathematical abilities when you have a calculator. So most of you will type in log 1 because you're worried, plus x cubed, but it's okay. You have your calculator, you're good. Graph. That's the graph of a sine 1 plus 1, and that's the graph of x cubed. Cool? Where do you think the solution is? The intersection. So we need to find the intersection. This is when you're going to go to second calc intersect. Second calc intersect. That's very important. You don't have the intersection once you press intersect. You're actually told you need to prompt the calculator on which curves to talk about. This is important if you have like more than 2 things graphed and you want to find the intersection between just 2 of the 3. It says first curve, question mark. Well, you could press up and down and it actually changes the equation that you select. So if you press down, you can see it changes to the x cubed equation. If you had a third one, you'd press down and it'd go to the third equation. But usually you only have 2 graphs, so you're fine. So we got x sine 1 plus 1. That's the first curve that I want to find the intersection with. So I will press enter. So that's the first graph. And it says, what's the second curve you want to select? You see the other equations already automatically selected. You'll press enter. And then it says, would you like me to guess? This is important to know. This technology is very archaic. The best it can do is approximate, and it usually doesn't even approximate that well, considering like where we are in 2023, almost 2024. Your calculator is guessing. You were probably one of the last set of students that are using graphing calculators. In like a year or 2, everybody's going to switch to Desmos. So, congrats. You press enter one more time, and look, it took your calculator seconds to find this intersection. Like, come on. We're better than that now, which we are, but that's okay. We got an X and a Y. The point is not your answer. X comma Y is not your answer. You are told that your X, which is representing your A, is 1.275. At that A value, you will get the same Y value. So you don't do X comma Y. It's the X that represents your A, gets your answer. If you plug in that value, you will get the same Y value. We have equality. Okay? So what you will find for a lot of these questions is that you have to provide the setup, and your calculator is used to just solve the equation that you have set up. Okay, but it's something that you can't do without it. And that you'll see occur a lot in the derivative rules unit, unit 2. Remembering that original equations gives us y's, and that Newton, that's not an N, and that Newton, our friend, took the limits and the slope formula, married them together, and created the derivative equation. The derivative equation gives you m's of the original equation. the derivative equation came from this marriage, limits and slopes. Keeping that in mind is important for the future. Now, these are no calculator, very basic questions that everybody in this classroom should be able to do. Let's see. Can you do question 1 and 2 by yourself? Without a calculator, it's a no calculator example. Okay. You get y minus 6 equals 9, x minus 2. You should get x equals plus or minus 2 over root 3. If you don't know how to get either of these questions, that's concerning. We need to do some work. It's really, do you know what to do with your derivative equation? Many of you are good at taking derivatives, just remembering what they can be used for. This is your M equation. This is your slope equation. 2 things you can do with that M equation. You can plug in x to get an M. Or you can set it equal to an M to find an x location where we have a certain M. If that second question baffled you, I'm concerned. That's an M value. This is not an M value. This is an M equation. This is why you don't see 3x squared minus 3 there. You see 9. Who knows? You plug in 2, you get 6. Remember, plug in x's get y's, plug in x's get m's. And then, don't forget, you get an M equation. You could set it equal to an M you're looking for, and you could solve. You get plus or minus 2 over root 3 or 2 root 3 over 3. All right, this is another good question. You guys remember the mean value theorem? Well, let's see. Change this interval to 0 to 1. The answer is 1 over root 3. But how do you get that?
Is it with that equation?
Yep, same equation, which is f of x equals x cubed minus 3x plus 4. Now, tell your neighbors, what is the mean value theorem? Because I actually don't expect you all to remember this. This is something that we should be reviewing, which we're doing. So, what is the mean value theorem? All right, here it is. You don't remember? I changed it to 0 to 1, sorry. Or else you're going to get the same question that we had before. If you have 2 points, you know that the slope connecting the 2 points gives you the average rate of change. You find an average rate of change using a slope formula. This is review. If you're asked for an average rate of change, you find the slope of the secant. Slopes equal rate of change. Like remembering interpretations, this 9 says at x equals 2, f of x is increasing 9 y's per x. If you found an average rate of change, you'd say over your interval, your function is increasing or decreasing on average this many watts per hour. Cool. Then, mean value theorem says that if you connect these 2 points smoothly, if your function is differentiable, there's guaranteed to be an x location, which you're trying to find usually, where your tangent slope or your instantaneous rate of change, which comes from a derivative, equals your average rate of change, which comes from the slope equation. So this question ends up being set up always when does your derivative equal your secant slope. You already have the derivative, 3x squared minus 3. You need to find this over your interval. I change your interval of 0 to 1. So you need to plug in 0 and plug in 1 to get the secant slope. Two minus 4 over 1 minus 0 equals -2. You solve this equation. And you'll get that. You'll get plus or minus 1 over root 3. We're only looking for the one that is in the interval. After lunch, we will do similar questions, but with a calculator.
I'm dropping out, so I don't have to say.
Unit 2, calculator active questions. The first question we're going to do seems like your calculator has all the answers, but it doesn't. You're asked to find the equation. Let's just find the slope of the tangent at x equals pi over 6. Find the slope of the tangent at x equals pi over 6. The issue with this question is I have no idea what the derivative is. Literally, I don't know what the derivative is. You got something in your ear, get it out of your ear. Besides me, I need this in my ear. I don't know what the derivative is. So how can I find a slope of the tangent? Well, we could go back to our friend, Mr. Newton. And Newton said, yo, you can actually just apply a limit to a slope formula to get a tangent slope. We could plug in 2 points very, very close to pi over 6. You do y2 minus y1 over x2 minus x1 with 2 points close to pi over 6. That's going to take a lot of typing in and a lot of calculation, which is why your calculator programmed in Math 8. Everybody go into your calculator and pull up Math 8. Okay, now all of a sudden derivative pops up. Now let's go ahead and do something just to try out, because we know an answer. We found the derivative of x cubed minus 3x plus 4 at 2. The derivative of x cubed minus 3x plus 4 at x equals 2, we found was 9. We got 3x squared minus 3. We plugged in 2. We got 9. Everybody get 9 using Math 8. Well, we go ddx, use the x button to find the derivative. X cubed minus 3x plus 4, typed in correctly. And I'm going to get 9. I don't get 9. Why not? Because your calculator approximates. What your calculator did is actually use a slope formula with 2 points close to 2. It didn't use a derivative. It didn't use Newton's discovery of equations. It uses old technology. and it approximates. Your calculator guesses. It told you that it guessed earlier. This is showing you how your calculator is guessing. So whenever you get a value close to a whole number, know that your calculator is guessing. Don't think that this number was wrong. This number was correct. We got it. Okay, but it enables us to find the slope of something we don't know. I don't know the derivative of x to the sine x. You could plug in math 8. It has to do with x to the x as being the parent function. I honestly don't know what the derivative of x to the x is. It's something I could look up. So we can math 8. X to the sine x at x equals pi over 6. You can either alpha f1 to pull up a fraction, pi over 6. Or you can just type in pi divided by 6. And you get the answer of 0.285. The actual derivative so it's x to the sine x minus 1 times sine x plus x log x cos x. Yeah, I have no idea. So anyways, math 8 helps you get approximate derivative. So the answer is 0.285 for x. Now, you think now that you have math 8, you can find all the answers to the rest of our questions easily. But really, math 8 is barely used on the AP exam. Because again, all it does is have you approximate a tangent slope, not really find a tangent slope using the derivative. So we have this question. We got a function. We're talking about x is bigger than 0. When does the instantaneous rate of change equal -2? And we didn't talk about this before lunch, so just to remind you. And it's important. This is unit 2. An instantaneous rate of change is synonymous with 2 other things. What are the 2 other things that mean the same thing as instantaneous rate of change? Tell your neighbors. Slope of a tangent's one, derivative's the other. I'm trying to find when the slopes are equal to -2. Now you might think, oh, math 8's going to help me. No, math 8 is not going to help you. Math 8 approximate tangent slopes at x locations. It won't help me solve when x locations will equal certain tangent slopes. So we actually go back to what we did without our calculator. We take the derivative, we set it equal to a number we're looking for. We did this with x cubed minus 3x plus 4. We took the derivative, we set it equal to 1, we solved. Well, we're going to take the derivative, we'll set it equal to -2, but now we won't be able to solve. It will be very hard, if not impossible, to solve by hand. This is where the calculator comes into play. So, again, this is a calculus test, not a calculator test. Start using your calculus knowledge. Take the derivative of x cos x, set it equal to -2. All right, everybody write down the derivative of x cos x. I got cos x plus negative sine x times x, and I'm trying to figure out when this equals negative 2. I try to solve by hand, I'm not going to have a good time. Tell your neighbors, how do you solve equations if you have a calculator? We learned this before lunch. How do you solve equations? Carlotti, put that away. How do you solve equations with a calculator? How do you solve equations with a calculator? How do you solve equations with a calculator? Y equals the left side. Y equals the right side. Graph the two sides. Find the intersection. Don't forget that. Oh, we'll talk about Windows later. Yes, we will have to change Windows. It'll help you tremendously. As long as you close your parentheses, you should be fine. All right, so I go y equals cos x plus negative sine x times x. Make sure you close parentheses, multiply by x. And I graph negative 2. And I press graph, and I get this graph. Comes off fine. And then I get a syntax error. You will get errors occasionally, people. Maybe you didn't get this error, but I got this error. Here's a little heads up, calculator words of wisdom. If you get an error, let your calculator show you where the error occurs. Go to. It will show you exactly with the cursor where the error is. Here, that's something wrong with that negative symbol. Oh, I used a minus sign instead of a negative symbol. It does not like -2, it likes -2. So, heads up, if you ever get errors, have your calculator go to the error. You will see these errors when you graph and you change your windows. You'll have these like dimension errors. Go to the error. See what exactly is wrong. All right, now I have multiple intersections. Did I do something wrong? No, it says for x is greater than 0, when does f of x first? All right, so I'm looking for our first intersection. That's greater than 0, yeah. Second, calc. Intersect. We want this first intersection might be valuable to cursor over to that first intersection. Enter, enter, enter. We get x equals 1.813. So this question, 95% of the work done to getting the right answer, I heard, involves the setup, taking a derivative, making sure you set up the equation so you have your derivative equal to your value, and then the last step is actually using your calculator. Your calculator there just to solve the equation. So, it's a calculus exam, not a calculator exam. Do number 3. .232 is the answer. See if you can get that. So, gentlemen, what we were talking about is, even though we have our calculator, it's really our calculus that's going to give us our setup. And most of the time, all the calculator is going to do is just help us solve equations that we have to set up. So if I ask you, when does this function have an instantaneous rate of change equal to that function? First of all, you think to yourself, what does instantaneous rate of change mean? What's another word for IROC? Slope of a tangent or derivative. Great. That's very important, guys, to make sure you have all of those translations. So you're trying to figure out when this and this have the same derivative. Do you think you could set something up for me? Okay, go ahead and do that. Why wouldn't that? It's worded a little bit weird, I can see that. But I kind of mean equal to each other. I think the wording is a little bit weird. You might think, when does F have a tangent slope equal to G? But I really mean, when does F and G have the same tangent slope? The wording is weird. That makes sense. I'm looking for that. This is F's tangent slopes. These are F's rates of change of plugged in X's. These are G tangent slopes. We set up an equation that our calculator solves. We get X equals 0.232. What? What? The next question? I don't think it's that. What did you do at X equals 0? That's not the location of the 0. Yeah, you're getting multiple choice questions on Wednesday. This is just calculator questions. That's your homework. We will have a quiz on Wednesday. Yeah. Okay. Question number 4 segues us into Unit 3. We got e to the tan x minus 2 from 0 to 1. What is the slope of the graph when it crosses the x-axis? All right. We're going to learn some things while doing this question, so pay attention, please. We have e to the tan x minus 2. If I press graph, I notice there's a lot of x-intercepts. I don't want all of these x-intercepts. You will have this experience where you press graph and you immediately regret it. Press the on button to pause. Sometimes you'll try to graph something and it's like, man, this graph is taking forever. I don't really want the entire graph. I just want a section of the graph. Everybody, the on button pauses graphs. Okay, so I just paused because I really just want the interval from 0 to 1. So everybody, you will introduce yourself to window. Now, window is where we can change our x's and our y's. However, I'd recommend we just change our x's using window. Now, if you press graph after you go from, 0 to 1, not negative 1 to 1. 0 to 1 for your x-min and your x-max. This is how you change the x's or the y's. You can see you have this, but again, it doesn't look great, but it's good. So let me introduce you something that might help you in the future. Zoom fit will automatically adjust your y's based on what you select your x's to be. So I adjusted my x's to be 0 to 1. Go to Zoom. Zoom standard is the negative 10 to 10 normal window that you're used to. If you ever want to go back to a normal window, use Zoom standard. You go to 0 and you get Zoom fit. Zoom fit adjusts your y's based on the x's you select. We'll use this more later. Now we get this nice graph that crosses the x-axis at one location. Where we cross the x-axis is our 0. We need to find this location here. So the next thing we need to learn is finding a 0. There are two ways to find a 0. You could do second calc 0. So everybody find the 0 location. I'll let you in on another little secret while we're doing this problem. Whenever you find something in your graph screen, now really quick, while we find the 0, it says left bound. It just says make sure you're to the left of the 0 you're trying to find. Right bound means you need to move your cursor to the right of your 0. Guess means, would you like me to guess? Really quickly, this is cool stuff that most students don't know about with your calculator. If you find a value in your graphing screen, everybody go into your home screen by going second quit. Quit is above mode. Go back to your home screen. Type in X right now. Press enter. The value you find gets stored as an X value in your home screen. If you want to, you could store it as a different letter if you want to. I could say, hey, store that X as an A. You press the store button, stores above on. It allows you to take any number, and whenever you want to recall that number, it's like, well, I have A as 0.606. Isn't that cool? So we'll use that a lot in the second semester when we're using our calculators more. We want to find our slope at that value. Now, the other way to find a 0 really quickly is the way I prefer. You could graph y equals 0. You don't see it, but it's there, and you can find the intersection might be a little bit quicker than doing left bound, right bound, because you just press enter, 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 and boom. That's how you find your intersection, your 0. You got 0.606. I'm putting dots after that because we want our slope at that point. We know how to find slopes for things that we don't want to take derivatives for, or they're hard to do. You could go into your home screen and math 8 it. Or, guess what? You're already in the graph screen. Go second, calc, and then you notice dy dx is right there. I can say, find the derivative, and I can either type in the 0.606111 number, or I stored x as that value, or I stored a as the value. The answer I'm looking for is 0.2963. Again, you could probably do that in your home screen, math 8. We are finding the derivative of e to the tan x minus 2. At x equals, I stored it as a, I stored it as x, or you could just type it in again to get 2.961. Real. No, your calculator doesn't allow you to do mean value theorem. You have to set it up. You'll have to find the slope. You'll have to find the derivative. What your calculator can do is approximate slopes and solve equations. That's most of what it can do. It can find zeros. It can approximate slopes. It can solve equations. Cool? And that brings us to unit 3, my favorite unit, because students get answers that make sense but aren't correct so often. It's really the first unit where it's like, hey, and you guys think the answer is this, and it's not this. And those are always fun for us teachers. So if you remember, unit 3 is all about the charts. A sign of a derivative tells us if an original thing is increasing or decreasing. Which means a second derivative sign, that's a second derivative, will tell us if our first derivative is increasing or decreasing. But turns out if we know if our first derivative is increasing or decreasing, our original function we know is curving upwards or curving downwards. Now let's do some no calculator problems. Go ahead. It's been a while. Here's a graph. Tell me, when does f have a max? When is f concave down? When is f decreasing at an increasing rate? See if we remember this stuff. See if you can do it. Go ahead and write down the answers. Good. Love to see this. A lot of people are wrong. That's okay. It happens. This is why we review. If you put x equals 0, you're wrong. If you put x is less than 1 or negative infinity to 1, you're wrong. It's okay that you're wrong. It's been a while since we've done these questions. These are tricky questions, especially if we haven't done them in a while. So we remember The chart. F has a max when F goes up then down. That's when F prime changes sign from positive to negative. Where does F prime change sign? Typically at zeros. F prime equals 0 when it crosses the x-axis. We just found zeros. When does F prime change from positive values to negative values? At 1. When F prime changes sign from positive values to negative values, F has a max. When is F concave down? Okay, I'm going to start with my chart. F is concave down when F prime is going down, or when F double prime is negative. What do I have? I have the graph of F prime. So I'm looking at when F prime is going down. If we just have our charts and are able to use them, we can get this right. F prime is going down from 0 to 2. Yeah, you did. When is F decreasing at an increasing rate? Well, there's 2 layers to things. F needs to be going down. That means F prime is negative. And F's rates are going up. F's rates are increasing. Oh, that's a second derivative sign analysis. If you don't remember these, you have some work to do before your midterm. We want when F prime is negative, because this is the graph of F prime, and when F prime is negative and going up. Now, some of us might just say 2 to 3, and we'd be partially correct. But we also have to pay attention to this right there from negative infinity to negative 1. All right, let's say we got those wrong. It's okay. It's been a while. Now we've reviewed. Here's another graph of F prime. Let's get these right. Now, the only thing different about this is you got some decimals. Well, this is kind of like leading us to what we're going to see these calculator active questions looking like. It's really just the same as what we're used to, but just with some decimals. Point of inflection, the curvature has to change. So F has a relative min when F goes down, then up. That's when F prime changes sign from negatives to positives. That's not at 1.125, guys. That's not when F prime changes sign from negatives to positives. Look for when F prime equals 0. That's at 0 or 1.5. Your answer is either 0 or 1.5. But only one of the two changes from negatives to positives, looking from left to right. X equals 1.5. Points of inflection occur where your curvature changes. Your curvature changes when your derivative changes direction. Not necessarily when your derivative equals 0. A lot of people will include x equals 0. That is not a point of inflection. It's when we have like a max or a min of f prime, where we change direction. F prime goes down, then f prime goes up at 1.125. Where are we decreasing at a decreasing rate? When f prime is negative and going down, that's 0 to 1.125. Okay, we're still reviewing. This is still no calculator. Here's one more, no calculator. Pay attention to what's given to you. It's all about the chart. Make sure you understand what's given to you. If you say never, you're wrong. If you say negative 2.3, or sorry, negative infinity to negative 0.5, you're wrong. Because this is the graph of f double prime. F double prime being negative means f prime is going down, means f is concave down. When is f double prime negative is what we're looking for. Here's when f double prime equals 0. Here, here, here is when it's below the x-axis and negative. Negative 2.303 and 1.303. You get my drift. Okay. Now, what does the calculator active unit 3 question look like? What's up? Oh, the second part was at 2.303 and at 1.303. Okay. What does the calculator active question look like? Well, it looks like this. No, like, don't do it. I can't. What's the difference between this question and the previous question? There's no graph. Well, that's because you have a graphing calculator. Look it up. You have an equation. You're going to want to graph the equation so you can see what the graph of the derivative looks like so you can answer all the questions. But again, when you graph, you got to understand what you have, or else you're going to make the same mistakes that you made on the previous question. So let's plug that in to y equals. Words of wisdom. Alpha F1 will bring up the fraction. That way you don't have to do lots of parentheses. You got x cubed minus 8x squared plus 3. We got squirt x cubed plus 1. Now you're going to press graph, and you're immediately going to regret your decision because you don't want that graph. Press on to pause. Okay? Press on to pause. I don't want it from 0 to 1. I want it from negative 1 to 9. So we go to our window. On pauses, go to your window. You will always be given intervals, almost always. Window, adjust your x's zoom fit, adjust your y. I'm going to adjust my x's and then zoom 0 or zoom fit to adjust my y. This is the graph of my derivative. The question is, when does f attain a relative max? Many of you will find the max right here, and you'll be wrong. That's not the location we're looking for. Again, it's a calculus test, not a calculator test. Not 1. You got to find the value. It's a decimal. Don't assume it's at a whole number. You got to find that location right there, and guess what? Not 1. You got to find it. Four 4.7. What is it?
We're doing X.
Well, once again, Schultz, many of you will find the maximum, and that's not what we're looking for. F is going to have a max. When F goes up and down, that's when F prime changes sign from positive to negative. This is the graph of F prime. We were just doing F prime graph questions. This is the same. The answer is not the location of the max. The answer is the location of this 0 right here. Second calc 0, not max. The 0 close to 1 is at 0.638. If you got an error, you didn't go to the left and to the right of it. Left bound is just go to the left of it. Okay. Let's go to this question right here. Skip one question, go to this question. The last question we have time for. I'll finish up the notes later. Here's the graph of f prime. You're given an x interval. But now they're asking you, when is f concave up? All right, here we go. Let's graph. Let's change our windows. Calculus is going to help you. The calculator will just show you. Calculator is not going to give you your answers. Your calculus knowledge will give you your answers. Don't press graph. If you press graph, you're immediately going to be like, oh, geez, I don't want the entire graph to be. Press on to pause. You go to your window. You adjust your X-min and your X-max. You zoom fit to see everything nicely. And this is my graph from negative 1.5 to 1.5. Okay. Again, you got to know what you have. This is the graph of f prime. I'm looking for when f is concave up. That's when f prime is going up, or when its slopes are positive. Since I have the graph of f prime, I need to figure out when it's going up. That is here. And a little bit right here, but let's just pay attention to here. How can we find this interval? Well, this is when we use our calculator's ability to find a minimum and a maximum. Second calc min will help us find the location of this min This will be the location of a point of inflection on the graph of f. Negative 0.240 to the location of the max, second calc max. So finding zeros, maxes and mins, solving equations, all things expected. Go to the left of the max, go to the right of the max.
I have a question for you and Chelsea. If you didn't know my age,